this chapter 1 for intermediate algebra. All right, so chapter 1, again, going to be a lot like a review from high school, from algebra 1, algebra 2. In chapter 1, we're going to be talking about linear equations. Okay, here's how I do the first 3 sections. So in the first 3 sections, I don't touch the word problems yet. I want you to learn the mathematics behind all these linear equations that we're going to talk about. And we're going to learn how to graph. We're going to learn how to write the equations. Um, we're going to learn how to find intercepts, both the y and the x. We're going to learn how to deal with parallel and perpendicular lines. That's everything that is in these first 3 sections. Oh, and slope, of course. So that's these first 3 sections. So we're going to learn those basic pieces of algebra first. Then I will worry about the word problems. So when you go through this, when you're doing the assignment, skip the word problems because you can come back to them. And generally, there's only like 2, maybe 3 in a section or less. Okay. So skip the word problems for right now. So just to remind you again, 1.1, 1.2, and 1.3, you're going to learn the math first. Skip over the word problems. And after 1.3, I will have a separate video that talks about word problems encompassing all of 1.1, 1.2, 1.3. Okay? If memory serves me right, in 1.1, there aren't any word problems. They really hit you in 1.2 and 1.3. And they're the same kind of word problems. That's why I want to wait and do them all together because it makes more sense. Okay? So I have also provided you some amazing notes basically for section 1.1 and 1.2. So these notes right here cover section 1.1 and 1.2. These notes are all about graphing, but you got to know how to graph in both of these sections. So just to kind of give you a heads up. So we're going to talk about mostly 1.1 today, but we will hit a few of section 1.2 concepts. And again, these are notes that are posted for you. You have access to these, and they talk about how we can do graphing. Okay. Also, I'm going to be showing you how the graphing calculator can help you out with graphing. Lots of good things right here. So you're going to get quite a bit of information in here. Lots of good information. Okay. So section 1.1 is all about graphing, and it's all about being able to graph in standard form. In other words, what they really call this is graphing intercepts. So they really want you to figure out the x-intercepts and the y-intercepts, okay? And so some of your high school teachers, they teach you this. Other high school teachers don't really teach you how to graph the intercepts, although they should. They mainly tell you how to graph and slope intercept. So here are the 2 equations that you really deal with dealing with lines. Most of you remember this guy, y equals mx plus b, the slope intercept, okay? Where y equals m was the variable that represented slope, x plus b represented the y-intercept, okay? The y-intercept. And all y-intercepts come in the point form of parenthesis, the 0 for x, and comma, whatever the number is for the y-intercept, which is your b, close the parenthesis. I believe I have it written out. Yep, right here. Y-intercepts look like this. Parenthesis, 0, comma, a number, which is your b, close parenthesis. So they want y-intercepts given to us a couple different ways. Sometimes they will just ask you for the b value. Sometimes they will ask you for the point. You'll see that as we go through and work these, okay? So remember that the b is the y-intercept, okay? Over here, this is standard form. This is ax plus by equals c. A big piece in algebra, especially when it comes to linear equation, is knowing what form you're in. Okay? So in class, I would always ask you guys, looking at these 2 equations, ax plus by equal to c, and slope intercept, y equals mx plus b, what is the big difference between these 2? How are you going to know if you have one form versus the other? Now, The big thing is you can't just say, well, standard form has A, B, and C, and slope-intercept has an M and a B. You're not going to see those. These A, B's, and C's represent numbers. This M and this B is a number. Okay, so it's not going to look like A x plus B y equal to C. You're not going to see an A. You're not going to see a B. You're not going to see a C. Okay, like this. I want to know how you know what form this is in. Because if you know what form you're in, then that tells you, is this a form that I can graph in? Can I actually graph in this way? Which most of the time you can. Okay, and I'm going to show you how to graph in both of these forms in this video. Or do you want to convert to the other form? Okay, because we'll talk about that too. So what's the big difference that you see between these two? And I'll give you a hint. It deals with the x's and the y's. That's right. Doing a little Dora Explorer on you. Hopefully you noticed that in standard form, x and y are on the same side. When it comes to slope-intercept form, they are on opposite sides of the equal sign. See? Same side of the equal sign, opposite sides of the equal sign. So another big thing is whenever you have y equals, that's slope-intercept. Okay? Whenever you have y equals, that's slope-intercept. But again, when you're looking at the equation, if x and y are on opposite sides, slope-intercept. If x and y are on the same side, standard form. Okay? So let's get to what they want you to do. Okay? So in here, really what's going to happen, and I'll show you an example of the assignment, of what you'll see in the assignment, but I want to walk through it real quick with you, just talking about this. So they give you this equation, and they're going to say graph it. Okay? Sometimes they scaffold it to get to the graphing. Sometimes they don't. Sometimes it's just like, here's the equation, go for it. So I want to talk to you about how we can graph. So first thing is, what form are we in? Hopefully when you look at this, you're like, oh, x and y are on the same side. What did Mr. Armstrong say? Oh, yeah, that is standard form. Okay? Well, then we can come over here and we can look. And right here, here's how we can deal with graphing in standard form. Okay? We can do what we call the cover up. Okay? We could convert it to slope-intercept. Or we could use a formula to get slope-intercept. Okay? So we're going to talk about all three of these methods. First things first, I want to talk about the cover-up. Right here, you can see the cover-up method. Okay? Right over here, this is the convert method. Down below right here, this is the formulas method. Okay? So, let's talk about graphing in standard and the cover-up method. So the cover-up method, it's 3 steps right here. You're going to cover up the y and solve for x. Okay? The reason why we can cover up the y, because look at how an x-intercept is made. It's a number, comma 0. We can cover up the y because the y value is 0. That means it doesn't matter. Okay? Now, if I was in class, you would hear me say, okay, so since the y value doesn't matter, all of a sudden I would go up to the board and I go, BAM! And I would cover up the y value and slap the board with my hand, yelling, BAM! So it would kind of look like this. I don't know. Nope, I can't get away with that. So what would happen is my hand would be covering up the shape and making it look like this so you could not see it. The y is gone. Bam! It's gone. So what do we have left? Okay? We have 2x equal to 6. That's what we have left. So what we just did is we covered up the y, and writing down what's left, you can see all we have is x. So we want to solve for that. How do I get the x value by itself? Divide by 2, divide by 2. X is equal to 3. So you now know that the x-intercept is 3, 0. Sometimes they will ask you for the point. Sometimes they will just ask you for the number. Okay? Make sure that you read that fine print below the box. If it says give me an integer, then they're looking for the number. If it says give me an ordered pair, they want the point. So make sure that you read carefully. And if you wanted to, you could go ahead and plot this. This is the x-intercept. It is at 3, 0. There's the x-intercept. Okay? All right. What does step 2 say to do? It says cover up the x and solve for y because you're looking for the y-intercept. Hence why this is all about graphing intercepts. Because when you're in standard form, you use the intercepts to graph. Okay? So we can cover up x and solve for y. Well, just like before, notice that the x value is 0. That's why we can cover it up. So we come back over to our problem and we're like, bam! It's gone. What do we have left? 3y equal to 6. Now solve, because all we have left is the y. So we find out that the y value is equal to 2. Or in other words, you just discovered that the y-intercept is 0, 2. And again, we can go up to our graph and plot that point, 0, 2. And now, all that's left, the third step says plot the 2 points, which we did, and you need to connect the dots. It's like, connect the dots, like, going from dot 1 to dot 2 to dot 3, so on and so forth. But you only have 2 dots. So we don't have to worry too much about connecting the dots. So I'm just going to grab this kind of guy and close enough. There's our line. Okay? That's graphing standard form. If you have standard form, I do what is called the cover up. So when I want to solve for the x-intercept, cover up the y. When I want to solve for the y-intercept, cover up the x. Okay? And solve and plot your 2 points. Now again, some of your high school teachers probably didn't teach you that or, did it quite as lively as what I did. Some of them probably just said, hey, if you're in standard form, why don't you just convert this to slope-intercept? Get the y by itself. Okay? So let's talk about this second method that we have in here called convert to slope-intercept. Okay? So we're going to take this equation, this standard form, and we're going to convert it into this, y equals mx plus b. You do 2 steps to do that. The first step, you're going to add or subtract x to the other side. Get the x piece away from the y, okay? Because in slope-intercept, they're on opposite sides. They don't like each other. So in here, if I'm going to convert this 2x plus 3y to slope-intercept, I'm going to take the 2x and move it away. Well, how do I move a positive 2x? Subtract it. Like I said, you're either adding or subtracting. So we have 3y equal to, now, do these two get together? That's right, they do not, because this has an x, this one does not. They are not like terms, do not put them together. So I'm going to show you 2 things. You could either write what you have like this, 6 minus 2x, there is nothing wrong with that. Or you can write it like this, negative 2x plus 6. So whether you put the 6 first and then the x part, or put the x part and then the 6 and then the 6, it doesn't really matter. Okay? Both of these are going to end with the same answer involved. Okay? So either one is correct. You do you, boo. All right? So the step 1 was all we had to do was move the x piece away. Now normally, Mr. Armstrong, I'm going to write it with the x first, because when we look at slope-intercept, the x is first and then the regular number. Okay? But it doesn't matter. I will not come after you. I will not haunt you if I ever die of corona or anything like that. Um, you know, you do not anger the math gods by putting the 6 first and then the x piece. It's a-okay. So the next step, step 2, says to divide all numbers by the number in front of y. So let's look at the number in front of y. It's 3. So every number over here is going to get divided by 3. Notice I didn't say variable. I said numbers. Okay? And I don't like doing this. I know some teachers taught you this. I don't like doing that. Granted, it's not wrong, but I don't like doing that because I want it to be separate like this, as in y equals mx plus b. And if you draw it like this, that's not really separate. Okay? I know you have to write a little bit more when you do it this way, but I'm very okay with that. You'll be just fine to take the 2.5 seconds it is to write a 3 under your numbers. So divide by 3, divide by 3, divide by 3. And the final step, all you have to do is make sure that all these fractions, because that's what you created, are reduced. And again, remember in your calculator, I showed you this in section A1. Alpha y equals is your fraction key. So if you put 6 over 3, because you don't know that reduces to 2, and hit enter, there you go. So let your calculator do any reducing that you need to. Let the calculator do the work. Okay? I don't expect you to do fractions by hand. That's just crazy. We got a calculator. And a free one to be at that. If you're using the TI-84 that you got from Texas Instrument, it's free. Let it do its job. So we know that 6 over 3 is 2. And then if you go to your calculator and put 2 over 3, you're going to see that that does not reduce. And you end up with that as one possible equation. So you can write it like this. Or, again, as I said, this is the way that I would write it. You'd have negative 2/3 x plus 2. Because this looks like y equals mx plus b. Both of them are correct. Just know that if you write it backwards, this is the m and that's the b. Because in our equation, the m is always next to x. The b does not have any variable. Okay, the b is always the number that's by itself. M is next to x, b is always by itself. Okay? So now that you've converted to slope-intercept, we can talk about graphing in slope-intercept. So here's how we graph in slope-intercept. Okay? That's on the bottom of the page. And I call it Google Maps. So generally, so if you hear me ever say this, if I say do the cover-up method, or BAM! Then I'm talking about graphing in standard form. If I say do Google Maps, then we know that we're going to be graphing in slope-intercept. Okay? So if I come over here and I graph according to this. So the first thing it says is find m and b. That's what all the converting was for. So we now know that m is negative 2/3. Okay? Now I'm going to put that negative right in front because I want to talk about that negative here in a second. And we now know that b is 2. Okay? All right. So the first thing you're going to do is plot b. Remember, that's the y-intercept. I remind you right there. And remember that the y-intercept is always written as 0, comma, your number. So if I go up to my graph and I plot 0, 2, I'm right there. Oh, look, that's the same y-intercept we graphed before. Weird. Okay, so that's part 2. We found the m and b. We plotted the b. And now we're going to use m. I don't say plot slope because you can't plot slope. Slope is directions. That's why I call this Google Maps. Okay? Slope is directions where the top number moves you up and down. The bottom number moves you left and right. Okay? If your top number is a positive number, you're going to move up. If your top number is a negative number, you'll move down. If your bottom number is positive, you'll move to the right. If your bottom number is negative, you'll move to the left. So let's talk about this. Notice my negative is in front because when it comes to negative fractions, you need to understand that that negative really has three places it can go. The negative can go out front, like what we have it. It could go into the top and leave the bottom positive. Or it could go into the bottom, leaving the top positive. Either way, you need this negative when it comes to slope to be in one of these two positions. You cannot put it in both because if you put a negative in both positions, what do you get when you take a negative number divided by a negative number? It is positive. It is no longer negative anymore. That's why you do not put the negative in both. You are changing the value of your number. Okay? So don't do that. You put it in one place, out front, up top, or down below. When it comes to slope, I generally put it in the top. Okay? But there's nothing wrong with putting it in the bottom. You get the same answer. Okay? Promise you. So this negative that's right there, I'm going to put it up top and say that it's a -2 over 3. So as we just talked about this, the top value, because it is negative, means that we're going to be moving down 2. The bottom number, because it is positive, means we're going to be moving to the right 3. So we're going to use those directions. Okay? So the reason why I call this Google Map is because when we plotted the B, that's Google Maps finding you. Okay? That's Google Maps right there using your location. And then from there, Google Maps is going to say, hey, grandma's over here. Okay? And it's going to say, these are the directions to get to grandma's house because you want to go to grandma's house because grandma is giving you the dessert buffet like no other. We've got fondue, we've got cupcakes, brownies, cookies, cake, ice cream floats, ice cream sundaes, whatever you want, grandma's got it. She's hooking you up. Okay? So this is Google Maps finding you. That's the B. Ding. And then this is Google Maps saying, make a U-E, go down 2 and to the right 3. You are at your destination. That's why I call this Google Maps. So if I go down 2, 1, 2, see I went down 2, and to the right 3, 1, 2, 3, boom, look where we just ended up. That's the same x-intercept that we found before. So that was to the right 3. Okay? Most of your teachers probably said take slope or take this standard form and convert it to slope intercept and then graph it from there. I don't care which way you go. You do you. All right? If you like graphing and slope intercept, graph and slope intercept. But I will tell you, generally, a rule of thumb for me, if I'm in standard form, I'm going to graph using the cover up. If my equation is in slope intercept, that's when I'll graph using slope intercept. Okay? It makes sense. Why do I want to try and convert this to another form and maybe mess up on my math and then get the wrong picture when I can just do a quick cover up and get my picture and all that stuff right then and there? Okay? This, to me, converting and then knowing all this other information, that's a lot of extra work. I'm all about keeping it simple. Okay? All right, so let me talk about this last method. Okay? So, use formulas to find the slope intercept. I mean, you already know how to graph and slope intercept, but instead of converting, I want to show you a third way to get to this just by using formulas. Okay? So right here, it is known that the M of slope intercept is the opposite of A over B. Now remember, these A's and B's that I'm talking about, they are the numbers that are in front of X, in front of Y, and the C is the number that it's equal to. A is always with X, B is always with Y, and C is always the guy by itself. Okay? So if I want to know the slope, M, all I need to do is take the opposite of the A value and slap it over B, and then of course make sure you reduce. If I want to know the B value, I'll take the C over the B, and then there's your equation. There are the two pieces of information you need to graph. Okay? So let's go back and let's look at this. So I'm going to change up my color so that way you can see that we're doing a different method. So this is the A, this is the B, this is the C. A is always with X, B is always with the Y, C is always by itself, because sometimes they'll mix this stuff around. So just know that A is always with X, B is always with Y, C is always by itself. Okay? So if I come down here, I can now find the M. M says the opposite of A over B. Okay? The A value up there was 2. The B value was 3. The C value was 6, just to remind you. So up here, what is the opposite of a positive 2? Negative 2. What's the B value? 3. Does that reduce? Nope. What is the B value then? Let's figure this out. In other words, the B of slope-intercept. So this is C over B, which is 6 over 3. Does that reduce? Yes, to 2. Oh, look at this. This matches this. Right there, you've got your equation. Y equals negative 2/3 X. Excuse me, sneezies. Plus 2. See, now you converted to slope-intercept. And now you can graph slope-intercept if you wanted to, just like what we did before. Okay? So really, I've taught you 2 ways to graph. You can do the cover-up method, bam! Or here are 2 ways to get the slope-intercept, and you can graph in slope-intercept. It does not matter how you graph on this, okay? But I will tell you, in this section, they really do want you finding the intercepts, the x-intercept and the y-intercept. Most of the problems in this section are going to be given to you as standard form, okay? Let's do another one because I need you to get really good at this. That was a lot of information that would take you generally about a week to learn in Algebra 1 and all that stuff, and the same thing in the Algebra 2. We're doing it all almost in one video. You're learning all about lines again. So go ahead, pause the video, give this one a shot, and go. Okay, so cover-up method first, and then I'll show you slope-intercept. So if we want to solve for the x, we're going to go BAM! It's gone. So the y value is gone. What do we have left? Negative 5x equal to 10. Okay? Divide by negative 5. Divide by negative 5. 10 is equal to, or x is equal to negative 2. So you know that the x-intercept is negative 2, 0. And you can graph that. Negative 2, 0. There it is. Okay? Then, if you want to find the y-intercept, BAM! Gone. 2y equal to 10. Divide by 2, divide by 2. Y equals 5. So your y-intercept is 0, 5. So we can plot that. 0, 5. 1, 2, 3, 4, 5. There it is. And then now you can draw your line. And yay, we've graphed. Good job, everybody. Okay? Now, if you did the slope-intercept, because some of you like to graph and slope-intercept, and there ain't nothing wrong with that. So if we convert this, so let's do that. Let's do a quick conversion. Okay. And I like to do the conversions for you guys right now because I know that many of you like to convert and you're not used to the formula method that I showed you. But there are a good time and place for the formula to convert standard form to slope intercept. There's always a good time and place for that. So in here, we're going to go ahead and add 5x to both sides because we've got to move the x piece. So plus 5x. So that gives us 2y equals 5x plus 10, because I always like to put the x piece first. And then now all we're going to do is the number in front of y is 2. We're going to divide everybody by 2. So our equation is y equals 5 over 2 does not reduce. You can check it in your calculator. X plus 10 divided by 2 is 5. So there's your slope-intercept. And now if we write out the slope, which is 5 over 2, the intercept, which is 5. So you can see that this intercept 5 was graphed. Okay? And then this tells me to go up 5 because it's a positive 5. And to the right 2. I don't know why I put that little line right in the middle of this. We don't really need it. All right. So if you actually do that from this, you're not going to end up at the other x-intercept. You're going to end up actually up here because you're going to go 1, 2, 3, 4, 5, 1, 2. That's where you're going to end up. But remember, when you were in Algebra 1 and Algebra 2 and all that stuff in high school, remember that you could also reverse these directions. What's the opposite of going up 5? You could have also gone down 5. What's the opposite of going to the right 2? You could go left 2. So if you reverse the directions, these are also the same slope. These are also the same slope. But now I know many of you are like, Mr. Armstrong, that's negative numbers. Yeah, I know. So this would actually have been a negative 5 over a negative 2, because going down is negative, going to the right is or going to the left is negative. What's a negative over a negative? Oh, it's positive. Oh, Mr. Armstrong, you're so smart. I know. That's why they pay me the big bucks. Okay? So if you went down 5, 1, 2, 3, 4, 5, and to the left 2, 1, 2. Oh, look at that. There's your other x-intercept. So weird. And it's the same line. Even though when we went up 5 and to the right 2, it wasn't, an intercept. We still got it if you reverse the directions. No, it's all good. You're good to go, okay? So there we go. Hopefully it's starting to make a little bit more sense. Hopefully you kind of like the BAM method. I think it's so much easier to deal with this when we're in standard form than it is to convert, to slope intercept and then do it. Okay? This is less work. All right. Go ahead, pause the video, give this one a shot. Okay, so again, starting with that cover-up method, the BAM method. I won't yell this time, I promise. So when you want the x-intercept, we cover up the y. See? Gone. No yelling. X equals 2. Well, there's no solving there. That's it. So your x-intercept is 2, 0. See? Nice and quick here, right? Now let's talk about your y-intercept. So we cover up the x. What do we have left? 5y equals 2. So you divide by 5, divide by 5, and you find out that y is equal to 2/5. And now you're like, Mr. Armstrong, I don't know how to graph fractions. Yes, you do. All a fraction is just division. If you go to your calculator and you take 2 divided by 5, you find out that it's 0.4. And now you're like, Mr. Armstrong, I don't know how to graph. 0.4. Yes, you do. This is my one thing about graphing. Graphing is not, it's okay. Okay. Obviously, if you're engineers, architects, all that stuff, you got to know how to graph and you got to know how to be accurate. But for us, 0.4, again, it's on a graph. You're going to get as close as possible to it. Okay. Graphing is not as accurate as what we would like it to be unless we're actually using technology to help us out. Then graphing is extremely accurate. But because I'm doing this by hand, it's a little harder to graph a 0.4. Okay, so we know that 0.4 is between 0 and 1. It's closer to the 0 side. So if I come up here and I'm going to put a little dot right there, and is that really 0.4? I don't know. Do I care? Not really, but that's close enough. It's good enough for government work, as I usually say. Okay, so you graph, if it's a decimal, as close as possible to that value. Now, if I remember correctly, in your assignment, generally when we have you graph, we try to keep things easy for you, so you should always be graphing on nice, neat points, like 2, 0, 5, 0, okay, 0, -7. All right, so we're going to keep it easy for you. But I just wanted to talk about what happens if a fraction and a decimal. So yeah, it's just do as best as you can. That's what I'm asking you to do. And there's our line. Okay, there you go. Dunsies. If you converted to slope intercept, nothing wrong with that. We've got x plus 5y equal to 2 minus x minus x. So that gives us 5y equals negative x plus 2. Okay? Divide by 5. Divide by 5. Divide by 5. Notice I didn't divide the x by 5. I divided the number that's in front of it. If you do not see a number in front of your variable, remember that it is the invisible one that we all know and love in algebra. Okay? So we got that. Now, writing out the last of our equation, y equals negative 1/5 x plus 2/5, because those fractions do not reduce. So if we look at the m is, and I'm going to put the negative up top like I normally do. Again, you could have put the negative in the bottom. It doesn't really matter. And then your b value is the 2/5. Okay? So if we were to graph this, okay, so we would plot the b value. And again, that's that 1/4 we plotted right there. Okay? And then what this tells us to do is to go down 1, right 5. So this is where graphing, like I said, it's not always the greatest. Okay? Because here you got to go from 0.4 down 1, which would actually take you to negative 0.6. And then you count over to the right 5. 1, 2, 3, 4, 5, roughly right about there. So you can see our line actually does kind of go through it. Notice again, you didn't end up at that x-intercept. Okay? Both of these methods, they have their advantages and disadvantages. Sometimes doing the cover-up method is great. Sometimes doing slope intercept is better. It's all about your style and how you like to do it. You can do all of these with the cover-up method. You can do all of these with slope intercept. It's your call. Okay? You do what's comfortable for you. Just know that in the assignment, there are going to be some questions asking you what are the intercepts. I want to give you a heads up on that if you like to use slope intercept, because sometimes slope intercept does not end at those x-intercepts. Okay? Or y-intercepts, I should say, too. Okay. So let's see what we got next on our plate. All right, so let's talk about what you're going to see in your assignment. Okay? So here's like what I showed you right here. So they're going to give you an equation, And the first thing is they're going to want you to fill in here. Now, in these boxes are going numbers because they are actually making you create the points. Okay, notice this is blank, comma, 0. That means this guy is going to be the x-intercept because that y value is 0. This is 0, comma, blank. That means this one's going to be that y-intercept. Remember, any point that has 0 for a y value is an x-intercept. Any point that has 0 for an x value, that's a y-intercept. Okay? So since we are in slope-intercept up here, standard form, we can easily do the cover-up method to find those two pieces of information. So if I want the x-intercept, let's redo that. Let's actually get this guy. There we go. So if I want the x-intercept, I just cover up the y. So what do we have left? Negative 2x equal to negative 6. Divide by negative 2. Divide by negative 2. X is equal to 3. So they want you to put a 3 in that box. Okay? The next one, we cover up the x, that's what we have to solve. Negative 3y equal to negative 6. Divide by negative 3, divide by negative 3, y is equal to a positive 2. All right, so there's the first part. Now, there are going to be two graphing pieces to this, okay? So let's talk about what they want in the first graphing piece. And the first one says, plot the intercepts on the coordinate system by choosing the black dot to the right below the graph. So what they want you to do is they want you to select this. Now I can't select it because this is not in the, this is just a picture of the homework. But you want to select this black dot right here. You're going to push on it. Right now you can see that the line tool is actually pushed. Okay, so you'll know it's been pushed when it becomes a lighter square. So you push on this, and then all you're going to do is you're going to, as accurately as possible, put a dot at 0, 2, and it will put a dot there for you. I think they end up being red when they actually are put on the screen. It's either red or blue. It's one of those two. And then you're going to put a dot at 3, 0. Okay? And you need to do this as accurately as possible because iMath.AS, this is what I don't like about it. It's very picky about where you put your dots. And if you are off just a little bit, like say you're right there, if you're off just a little bit, it will mark it wrong. I'm hoping that we've gone back through and put in the snap feature to it, but sometimes we forget to add the snap feature to this so it doesn't have that problem. So if it's not snapping, and you'll know if you got this wrong because it'll have a red box around it or a yellow box. If you have a red or a yellow box, that means you need to go back through and check your points and make sure that they are as accurately placed as possible. A green box around your answer means, hey, you did a good job. Okay, green boxes are good, yellow, red boxes, bad. If this thing would only graph. All right, and that's what they want. That's it. For part B on this one, they just want those two dots. Okay, so it takes 2 clicks to complete part B. All right. Part C, okay? Now you're going to choose the line tool, which is already selected here, okay? And you're going to graph the line by choosing, okay, we're just going to graph the line. So how this line tool works, you see 2 dots here, okay? This dot and this dot, those are going to be the points that you graph. It doesn't matter which point you start with, okay? As long as you pick one point to begin with. So for instance, I can graph the x-intercept, which was 3, 0. So I've got a line tool that I graph to kind of demonstrate what's going on. So I got 3, 0 here. So as soon as I move away from that, you see my line is following my. As soon as I clicked on that intercept, the line starts to move away. Okay, and your second click should be the next intercept, which is 20. And once you click on that second one, the line will solidify. And in fact, the line will actually go all the way through. It will be all the way across your graph because I'm not really using the correct line tool here. You're just seeing where I clicked and let off. But again, this takes 2 clicks to complete this problem. After you select the line tool, you click on one of the intercepts. So this time I'll do the y-intercept. And then your second click is on the other intercept. So you see how I was a little high on that one? iMathAS would count that wrong. Okay? So I would have to adjust it. All right? So it takes 2 clicks. First click one of the intercepts, it doesn't matter which one, and then scroll over to the second intercept, click, and there's the line. All right, so that's what one piece of your homework is going to look like, one of the problems. Okay, very involved with the graphing. And then after this problem, or 2, they're going to do the same thing again. But this time, there's only one graph. And if you read these directions, there's a lot more to do. I'm going to talk about these directions in just a second, okay? All right, so just like before, you're going to find the intercepts. That part hasn't changed because this is the information you're going to use to graph. So we're going to find the x-intercept, which makes it pretty easy because you get x equal to -4 when you cover up the y. So the x value is -4. It's a horrible 4. Let's fix that. Okay, and then to get your y value, cover up the x. We've got 4y equal to -4. Okay, so we're going to divide by 4. Divide by 4. Y equals -1. So now you know the y value. Oops, that's not what I wanted. -1. And so now let's talk about graphing. All right. So the first thing it says to do is plot the intercepts, choosing the black dot. Okay, so you're going to come down here, click on the black dot, and then plot those 2 intercepts that you just found. -4, 0, and 0, -1. So -4, 0, and 0, -1. So that right there, this first part takes 2 clicks for the 2 x-intercepts, or x-intercept and y-intercept. And then you're going to click the line tool. Okay? Then you're going to click the line tool. Okay, I clicked my line tool. And then you're going to do 2 more clicks right back over those intercepts. Click on one of them, then scroll over and click on the other one to have the line form. So it's a lot like what we did right here, although they scaffolded it for us. You did the 2 intercepts, and then you did the line graph separately. And this one, it's taking those 2 graphs and putting them together. Okay? So then, after that, you'll need to click on the line. Click on the line. And then it will be 2 more clicks after that to graph the line. Okay? So a total of really like 5 clicks on this. If you're not counting the first time, you got to click on the dot. And the same thing on these other ones. I'm counting, the 2 clicks that you actually do on the graph. I am not actually counting the time where you click on the dot. Okay? Because technically that would be 3 clicks total for this because you got to click on the black dot. Down here, it's still only 2 clicks because the default is to be on the line, just so you know. Okay? So when you do part B, it really is about 5 clicks. If you don't count clicking on the dot. So once the dot is selected, click, Come down here, click on the line, and then go back up and click again to make the line. Okay? You got to have all that, otherwise it's going to count it wrong. Even though when you actually graph the line, it's going to recreate your dots. So it's so absurdly obnoxious that it's going to make you plot the x-intercepts and y-intercepts, and then when you make your line, it plots the same points again. But whatever. I didn't write this question. So that's how you're going to do some graphing on your assignment. And that's how a lot of this line graphing is going to happen. Okay? I want to show you some things on your calculator. So just talking about your calculator, if you are wanting to graph using your calculator, because there's nothing wrong with that. I have no problems. Okay? Show you some nice little features here. So when you're ready to graph, you're going to go into y equals. Okay? Our graphing calculator only works in slope intercept. So if you plan on using the graphing calculator to help you out with these lines, which again, it does not bother me any. Do whatever you want. You do you, boo. Okay? You got to make sure that you're in slope intercept. So if we go back and we go back to the beginning and look at what we got here. So this was the very first problem. I could not put this into the calculator. I cannot put 2x plus 3y equal to 6 into the calculator. It's not going to work. It has to be like what we have right down here in red. It has to be one of these two equations. And normally I just put it in like this. Okay? So this is why I also showed you your fraction key, because you'll be able to put the fraction in just like this, the way that you see it right here. Okay? So we're going to put in negative 2/3 x plus 2. So we're going to go to our calculator. We're in y equals. Please know that this is the negative button right down here by the enter. This is the negative button. Do not push minus, because pushing the minus, let me show you the difference between these two. See the difference? The minus is longer and it's lower. The negative button got raised a little bit and it's shorter. The calculator knows the difference between these two. And if you push minus and try to graph, calculator says error, because it's like minus what? You didn't tell the calculator what to do. There's nothing in front, and if you get an error, you just hit enter and then go right back into y equals. You didn't tell the calculator what to subtract from, okay? So your calculator knows the difference between a minus and a negative. So that first number is a negative, not a minus. All right, our fraction key, our friend, alpha y equals, hit your fraction. 2/3. Now scroll over. So there's the negative 2/3. Your X button is right here next to alpha. This is the X button. This is what we use in the graphing. Do not hit alpha and come down here and hit stow and use the green X. That is an incorrect X. This is the X value you need to use right next to alpha. So click X. And then I believe it was plus 2. This equation, oh, it looks just like that one. It's so amazing. Okay? It's great how our calculator takes what we wrote right here and it makes it look the exact same way. So now you can go and hit graph. And there's what it looks like. So you can know whether your picture out here looked right or wrong. So kind of comparing those two pictures, this line and that line. Yep. Hey, look, you can see your x-intercept. It was up at 2. Your y-intercept was over at a positive 3. Oh, that matched. Okay. Other things. If you hit second and graph, right here is a table. Okay, and you can scroll up and down on this table. And so if you want to find the x-intercept, find the point that has a 0 for y. Oh, right there. There's my x-intercept because the y value is 0. If you want to find the y-intercept, find the point where x is 0. Oh, look, it's right there. So right here, you can use your calculator to answer all those questions. You don't actually have to do the BAM method. You do have to know how to make sure that your equation is in slope intercept, but you can get all that information by typing in slope intercept, hit graph, okay? And then if you want to look at a table, hit second, graph, and then there you can look at the table. You want the x-intercept, look for when y is 0. You want the y-intercept, look when x is 0. And again, you just scroll up and down. And this table will go on forever and ever and ever and ever. Okay? It actually does not stop. Okay? Pretty cool. If your graphing calculator is messing up, just go ahead and hit second and the plus sign. And right here, you can go to a reset. Okay? And tell it to reset, should be all defaults. Okay? Or if you just want to do all RAM, you can do that too. Because if you're borrowing the calculator, if you're using the calculator from TI-84 that you download, it's not going to do anything. If you're borrowing a calculator from someone, probably go with the defaults. Just some general things like that. Some other general things. If you are borrowing a calculator, a couple things that you might want to do. After you put the equation in, I would go to Zoom and go down to Zoom Standard. Okay? Go to Zoom Standard. What Zoom Standard does is it puts it in this window frame where it goes from a positive 10 to a positive 10 to a negative 10 to a negative 10, because that's the same kind of graph that I have right here. Positive 10, negative 10, negative 10. Again, that's under Zoom Standard. Okay? So those are some things that can help you out with graphing. Just one other thing, other than, if you put in the wrong sign. If you see any of these, plot 1s, plot 2s, plot 3s, and it has a dark box around it, you need to make sure that gets turned off. That means somehow these got turned on, and we do not want these turned on. So if you see a black box around these, scroll up to it, click enter to turn it off. Another thing, if you graph, just kind of giving you some heads up, if you push graph and nothing's happening, go back into your equation and look at the equal sign. There should be a black box around the equal sign. If there isn't a black box, like this, right here, there's no black box, scroll over to it, hit enter, because you need to make sure that your equation is turned on. So having a black box around the equal sign, that's a good thing. That means it will actually graph. Okay? So there's some quick fixes to some things. Make sure that your equation's on with a black box. Make sure these are turned off. There should be no black boxes around them. Go to Zoom, scroll down to number 6, Zoom Standard, hit enter, and generally that fixes a lot of things. If that doesn't fix it, then do what I did with the memory reset. Second plus sign, scroll down to reset, and I would try defaults first. If that doesn't work, then I would do all RAM. Okay? All right. So there we go. That's how your graphing calculator can help you out. And we will definitely use this graphing calculator pretty soon. Definitely when we get into chapter 2. Okay? We're going to use this graphing calculator pretty heavily. All right. So just wanted to give you some heads up on that. So you can have the graphing calculator help you answer these questions right here using the table. And then from there, you've got all the information you need to graph. Okay? So pretty nice. All right. So there's the bulk of 1.1. We're still not done yet, still a little bit more. So then you're going to run into these bad boys. Okay? So what you have right here, these are special kinds of lines. Okay? They're actually horizontal lines and vertical lines. Let me tell you which one is which. All right. Horizontal lines are all y equals a number. Now, I know many of you will be like, Mr. Armstrong, that makes no sense because horizontal or y is to the sky. I know that rhyme, Mr. Armstrong. Y to the sky. Okay, y is up and down. Well, I'm going to tell you horizontal lines are y equals a number. Plain and simple. I'll give you the reason why here in just a moment as to why that is true. Vertical lines, well, then they are x equals a number. And then now many of you are throwing your pens and pencils across the room going, what the hell is going on? Okay. Well, I'm not lying to you. Y equals a number is horizontal. X equals a number is vertical. Plain and simple. Okay. So let's go back over here and let me tell you how to graph these, and then I'll explain why these are the way they are. So let's graph the first one. So y equals 3. So since this is y equals a number, I know that this is a horizontal line. So if I go to graph this, they make it real easy for us. This tells you what axis, and this tells you the number. So this says go to the y-axis, put a dot at 3, and we know it's going to be horizontal from there. So y-axis, here's 3. I'm going to mark it, and then I'm going to draw horizontally. There is what this graph looks like. That's it. That's how we graph horizontal lines. It says go to the y-axis, put a dot at 3, and it better be horizontal line. And there we go. And I could stretch this into all the way over to the other side too. It could look like that too, but I could stretch these out further, just like this. So however long you draw your line, well, that's up to you. Okay. But it really is that easy. Okay. Now, when you're doing it in the system, basically what you will do is you will plot that first point, okay, using your, make sure that you click on the line tool, and then you'll plot the first point, which is what they tell you. And then as soon as you move away, you'll see the line form, and then all you do is click on another point anywhere along this line. So click right there, and the line will be horizontal. So you just click on any other point along this line. All right. Now let's talk about this guy. So since this is x equal -5, so that is x equals a number. We know this is a vertical line. So again, it's kind of almost foolproof that they are telling us, that's not what I want. I want this guy. There we go. Okay. So they are telling us that we're going to go to the x-axis, and we're going to put a dot at -5. So x-axis, 1, 2, 3, 4, 5. So you plot that first, and then as you move around, you can see your line forming. So it's vertical, so we're just going to plot any one of these other vertical line dots. Okay, just like what we talked about with the horizontal. So we're going to plot anywhere that we want along that line. So I'll just do right down here at -5, -10. Okay, and there's the line. This is the line of x equal -5. And of course, it should be over a little bit more. There we go. That's it. Now, let me explain why these are the way they are. So let me give you the mathematical version first. So for your y equal 3, what this is telling you is that all y values have to be 3, no matter what. So then what can the x values be? Well, they can be anything. Doesn't matter. There's no restriction on them. So the x values could be 7, 0, -3, so on and so forth. It doesn't matter what they can be. They can be any number. So if I go and plot that information, 7, 3, 0, 3, -3, 3. What kind of line would I make if I connect all those? horizontal. Because you are making the y value 3, you are making the only possible points at this y value of 3, which is going to run horizontally. Hopefully that makes sense. And the same thing happens for the x value. What you have done here is you made the x value nothing but -5. So what can the y value be? Whatever it wants. It could be -7, 1, 5, any value you want here. The only thing that must be satisfied is that x is -5. So again, if I go and graph this, -5, -7, -5, 1, -5, 5. Should be 3, 4, 5. Yeah, right there. And again, if I connect all those dots, what did I make? A vertical line. Okay? Now, here's Mr. Armstrong's other way of thinking about this. Okay? This is the logical way. This is the mathematical reasoning behind it. That's why they look the way they do. Okay? But, show you something else here. What color have I not used? I got green, I got red. All right, so let's say that you say that this truly is horizontal. Let me give you some other equations. X equal 2, x equal -3. So if these are all horizontal equations, and if I graph them, they will look like this. So -5, there's my horizontal line, because you think that x equals a number is horizontal. Here is my x equal 2. Okay. Here is my x equal -3. So that means all three of those lines lie on the x-axis and are actually the same line. Are all three of these lines really the same line? No. Okay. All three of these lines are not the same line. Okay, they're not the x-axis. So if you're telling me that these are all horizontal lines, then any value that would be x equal a number will always be on the x-axis. It will always be the x-axis, and that is not the case. These three are different lines. I should be able to see 3 different lines out here. Now, I know you can see them because I color-coded them, but if I did them all in the same shade, you would not be able to see them. If I made them all red, okay, you wouldn't see them at all. So my case in point here is there's no way that these can be horizontal because these are 3 different lines, and if they were horizontal, they would all be the same line, and we know that that's not true. All right? Okay, so let me give you 2 problems to try on your own real quick. I just want you to go ahead and graph these on a piece of paper. You don't have to make your piece of paper very big. Let's say graph the line y equals -5 and graph the line x equals 8. Graph those 2. Okay? Y equal -5 and x equal 8. And pause the video. Go! All right. So if we graph these lines, let's see here. Anybody that I can use? Kind of used them all. That's all right. So let's go back. Just grab this. I'll keep it black. All right, we'll do black dotted. There we go. So if you did y equal -5, so you know that this is horizontal and we're at -5. So down here. So if we were on our system, we would click the line tool and then we would come up here and go 1, 2, 3, 4. Here's the first click. And then we'll come out here and my line would form. And then you can click any other dot on this line. So we go click right there, and then the line would solidify, and you would see this line all the way across there. There is the line y equal -5. Okay? X equal 8, you know this is vertical, so you would come up and click the line tool. Then you would click on 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you would click any other dot along this. So let's just go, I don't know, I think that's 5. So you click right there, and then as I said, your line would form. And so here is the line, x equal 8. There you go. It is that easy to graph horizontal and vertical lines. So you'll see some of those in this assignment, horizontal and vertical. And that pretty much, you now know how to graph everything. Last two problems that you'll see in here. Make sure on this. Yeah. Last two problems. So they're going to want to know what are the answers to these. Okay. So you could do the cover-up method to this, but I want to tell you another way to do this. Okay. Because you might not be in the cover-up method type way. You know, maybe they have this in slope intercept, which would actually look like this. Y equals -3x plus 12. So what if you're in this? You can't do the cover-up method to find these two. So that's why I want to tell you this. You can always find the x-intercept and the y-intercept manually. Remember, we're telling you for the y-intercept, because that's what this guy is, because the x value is 0, that x is 0, right? So take this value, plug it in for x, and figure out what y is. That's another way to do it. That's why we can cover up the x value up here, because if I plug 0 in for this, what's 3 times 0? 0. It's like it doesn't matter anymore. So you can always take the values they give you in here and plug them in. So 3 times 0 plus y equal to 12. Again, 3 times 0 we just talked about. That's 0 plus y equal to 12. Well, you can add or subtract 0 to the other side, but it doesn't really matter. In the end, you find out that y is 12. Go ahead and try the other two right here. Pause the video and do it where you plug in. Okay. So on this one, you're finding the x-intercept because the y value is 0. So we're going to have 3x plus 0 equal to 12. You can add or subtract the 0 to the other side, but technically the 0 doesn't really matter. It's not going to change anything. So you really have 3x equal to 12. Divide by 3, divide by 3. You now know that the x value is 4. Okay? Now this one down here, they just want you to find a random point. That's all they want you to do. Okay? So all you're going to do is take the 2 and plug it in for y and then figure out what your answer is. All right? So we're going to have 3x plus 2 equal to 12. So subtract 2. That gives us 3x equal to 10. Divide by 3. And you go to your calculator, see if that reduces. It does not. So the answer they want in the blank is 10 over 3, or 10/3. That's what they want. Okay? Easy peasy. So you don't always have to do the cover-up methods and stuff like that. You can actually manually solve for these. All you do is take the value they give you, plug it in for either x, or plug this guy into y, and then solve for the missing variable. Simple. And then another question they're going to say, which one of these points is on the line? Which one of these points is on the line? Or in other words, is a solution. So again, all this is a plug and chug idea. If you want to know if something is a solution to an equation, you plug it in and see if it works. So for instance, let's take this x, because the 1 is x, the 2 is y, because points are always made up of x, comma, y. That's a horrible y. Let's fix that. So let's plug in. 2 times 1 plus 3 times 2. We want to know, is that 6? Well, 2 times 1 is 2. 3 times 2 is 6. Is 2 plus 6 6? Nope. So we're not going to select that answer. Well, let's do the next one. So we're going to do 2 times 2 plus 3 times 1. All right, 2 times 2 is 4. 3 times 1 is 3. Is that 6? Nope. So now the choice is down to one of these two. Go ahead, pause the video, give it a shot. You know what's going on. You're just plugging in. See which one is the real answer. Okay, so hopefully you picked this one, because when you actually plug into this guy, you get 2 times 6 plus 3 times a negative 2 equal to 6. Well, 2 times 6 is 12. 3 times a negative 2 is a negative 6. And 12 minus 6 is indeed 6. If you plugged in this one, it wouldn't have worked. You would have found that you'd had a negative 4 plus 18 equal to 6. And that is sure not 6. Okay? So, there you go. And that, my good friends, is section 1.1.